Hi everyone, thank you for joining us. We have Chris Cooper here today conducting a training on Campbell Fittings Combination Nipples versus Crimpnology Nipples. If you have any questions during the webinar, you can use the question feature and we'll go over all of your questions and comments during the wrap-up section at the end. So without further ado, I'll pass this over to Chris.
Hey, thanks Courtney, and good afternoon everybody. Thanks for joining one of the Ideal Trident Group's webinars. Hopefully you get something from this. I've been on seven of these so far just as an observer, and it's quite different for me, as I'm sure it is for you to some extent. So I hope you enjoy it. And so I am the Rocky Mountain Region Sales Manager for the Ideal Trident Fluid Power and Conveyance Group, and let's move right into the there we go. Hopefully you can see that. So the first slide is actually this picture is taken about 50 feet from where I'm sitting. I'm in Colorado, and that was just outside the front door. That big boy was just kind of relaxing in the front yard. So I thought we should start here. Don't just sit there. If you have any questions, there's a box in your panel to the right-hand side of your screen. You can type those questions as we go, and we'll address them. We'll address them afterwards. So just type them in the panel. Sorry there for the phone ringing. Schedule 40 standard combination nipples. Let's start there. The application is liquid transfer, bulk handling, and low pressure air. Probably most of you are familiar with this, but I'm tailoring this presentation so that you get the full gamut of information on combination nipples and Crimpnology nipples. I'm not sure that any of us really have gone through this subject in this kind of depth, so here we go. Primary hoses are multi-purpose and utility hoses, some transfer hoses with a lower pressure rating. The standard combination nipples are available in threaded, grooved, and beveled. On the left-hand side there, you see threaded is a 1/2 inch through 12 inch in steel, plated steel, and 3/16 stainless steel. 1/2 through 4 inch in brass, 1/2 through 6 inch in aluminum, and 1 inch through 4 inch in Hastelloy. Grooved parts, 3/4 through 12 inch in steel, 1 inch through 8 inch in 3/16 stainless steel, beveled 3/4 through 12 steel, and 1/2 through 12 and 3/16 stainless. The features of the standard Crimpnology nipple you'll see on the right-hand side of the screen. You have a straight lead insertion for easy insertion into the hose. So that is not oversized, so it will easily slip into the hose, whatever the nominal ID of the hose is, for easy insertion. You got a multiplicity of serrations to accept, grip, and seal all varieties of hoses. And these standard combination nipples are manufactured in Boyertown, Pennsylvania. We do have reducers and expanders in steel, plated steel, and 3/16 stainless steel. And the standard combination nipples take sleeves only. There is no machined groove to accept the ferrule, and those sleeves come in 2 lengths. The short sleeve is compatible with up to and through the 4 inch standard combination nipple, and standard sleeves, which are a little bit longer, are compatible with the 5 inch through 12 inch sizes. And on the smaller combination nipples, you can see that in 3/4, 1 inch, 1 1/4, and 1 1/2 inch sizes, there is a formed hex wrench area for easier installation. That is designed for, rather than turn an entire 20 or 30, 40, 50 foot hose into a pipe drop, you can put a wrench on it And obviously, you still don't want to spin the fitting in the hose. You never want to do that because the serrations will cut the inner tube. But that is for ease of installation, that formed hex. And the chart on the left is the Campbell crimp specification guide, or what we refer to as the crimp chart. You would use this to determine the actual crimp spec for these products, the combination nipple and the Crimpnology nipple. And that gives you the performance rating that Campbell actually publishes. So no matter what the parts or product, you're going to use this chart. And so, low pressure transfer hoses. This is a picture actually I took up in Williston, North Dakota. It's likely cam lock ends on for connection, but perhaps this might be male ends with threaded A's and D's. So this just gives you an idea of perhaps the kind of application it might be used on. We get into the Schedule 40 and Schedule 80 Crimpnology nipples. And this class of nipples includes the fixed and floating flanges, the Frack 16C Frack fitting, the one-piece 206 and figure 100 unions, and the Criminology Swivels. So these are designed for higher pressure critical applications, chemical transfer, petroleum transfer, mainly your chemical transfer might be air, smaller ID air. The bull air uses what we call the heat wave, which is part of the ground joint line. And pressure ratings of this particular line of Crimpnology nipples is up to 1,000 psi with the long shank, and we'll get into that in a minute. So you can see the turn backs, just as a note, in the picture on the left. You'll see a fixed flange on the very right side of the picture on the left, and then kind of next to that is the turn back, which is more or less a flanged fitting that accepts a floating flange. So it's got kind of a lip on it. So in the center picture, the attributes of the Crimpnology nipple, you'll see that at the end you've got a relief bump for tube abrasion protection. So that relief bump just takes a little pressure off the end of the nipple on the inner tube of the hose, and to prolong the life of the hose itself. And then you have variable pitch serrations. There's a multiplicity of serrations as well, just like the standard combination nipple. These serrations, however, are variable pitch, which means towards the relief bump end of the fitting, they are rounder serrations for improved sealing power. And towards the threaded end of the serration pattern, you'll have sharper serrations for maximum holding power. And now if we were doing this live, I would be handing one of these out, and if you rubbed your thumb down the serrations, you would actually feel that they're much sharper at one end and then soften towards the other end. So that is a design feature to get the maximum performance out of the product. And then, of course, one of the main features on the Crimpnology nipple line is the 360-degree precision machined interlock groove, which accepts the ferrule turn-ins for a mechanical connection, and that gets you to a higher pressure rating in terms of performance. And then the picture on the right-hand side, it is available in a standard and a long shank version. We'll get to the differences of those. The long shank, obviously, those two, the picture of those two fittings, they're different sizes. So one looks a heck of a lot longer, but the long shank has additional serrations on it and is made from Schedule 80 pipe. So the Crimpnology ferrule connection, if you were on the webinar this morning, Tommy did a webinar on the Crimpnology system. This is the same illustration, and it's very important to understand that when you're using a ferrule, you're actually interlocking into the groove of the fitting on the Crimpnology nipple. That's what gets you to a higher pressure rating. And of course, the fitting, you can see the hose is compressed into all of those serrations. That's what gives you the sealing and holding power for the performance rating. And again, the picture on the right, the crimp specification guide or crimp chart, you use that in all cases to achieve the rated connection performance that Campbell prints. So we actually publish the rating performance of the connections. So I encourage you, if you were not on the webinar this morning, to get on the webinar next Wednesday afternoon. It's a repeat. Tommy will be doing the Crimpnology webinar again. And of course, one of the main components of the system is the ferrules and sleeves. So you use the crimp chart to determine the correct ferrule or sleeve choice based on your fitting selection. So as you're looking up your crimp spec to actually finally crimp the product on the hose, when you're in the chart, right next to it, to the actual hose wall dimension will be the appropriate size ferrule or sleeve to use for that crimp procedure. So this is just an overview of the ferrules and sleeves that we have. We make more ferrules and sleeves than anybody in the industry. And you can see on the right-hand side there in the ferrule class, the ferrule category, we make sizes to fit different hoses and ODs because we don't know what hose you're going to be using and we don't know the wall thickness or the OD of the hose. So the standard ferrule runs from a 3/4 inch class to an 8-inch class, and that there's 62 different sizes within that class in plated steel, and it runs a 1/2 inch through 8 inches in the 304 stainless steel ferrules, and there's 60 sizes within that. In the long ferrule, it's a 1/2 inch through 4-inch sizes. And there's 59, the 1/2 inch through 4-inch class with 59 different sizes in plated steel. And the heavy duty ferrule, and we'll get into these things a little more later in the presentation, but the heavy duty ferrule is 4-inch only, and there are 6 sizes in plated steel. All ferrules, the size jumps in 1/16 inch ID increments. And so in the sleeves, the center picture, standard sleeves run from the 3/4 inch class to the 12-inch class with 93 plated steel sizes. 3/4 to 12-inch with 77 304 stainless steel sizes. Short sleeves, the 1/2 inch to 4-inch with 68 plated steel sizes. And in the 304 1/2 to 4-inch in 66 sizes. And in the sleeves, it's 1/32 inch increments from size to size. And when I say that, you'll look at the kind of yellowish picture in the center that says standard ferrule 2-inch size class above it. So that's a representative sample of the catalog, and this is a good opportunity to show some of you what the part number means. You can see they're all 2-inch size ferrules, so they're all in the 2-inch class. But that is the size run for the standard 2-inch ferrule. Starts at 2 32/64, which is a 1/2 inch. So it starts at a 2.5 inch ID. That part number is FPS, which is ferrule plated steel, 200 for the 2-inch class, and 2 32/64 for the actual ID of the ferrule. And so you can see it jumps 4/64 or a 1/16 of an inch each jump in size, and that's how you know kind of with the part number what you're dealing with. And the last thing, the light duty ferrules, they're for universals, the Bose and Thor fittings. They're very light. And they come in the 1/2, 3/4, and 1-inch class, and there's 13 sizes of plated steel, 304 stainless steel with 32nd inch increments. And of course, just to reiterate, in case some of you are new to this, ferrules have a turn-in and cut slots, that bottom left picture, whereas sleeves do not. Sleeves are more or less like a soup can with no top and bottom. And actually, a little story, our engineer back in the day, 20 years ago, had been around soup can manufacturing, which is split steel, rolled and welded. That's how they make the soup cans. And so that's kind of where this started for Campbell Fittings 20 years ago, was the manufacture of the sleeve in the style of the soup can. And from there, 20 years later, we're the leader in the Crimpnology segment of hose attachments. So this bobcat is actually about 60 or 70 yards from where I'm sitting in the side yard at my house here in Colorado. So this is just a reminder, as we go, if you have questions, that box, just type them in and we'll address those all at the end. It's a pretty cool bobcat. Anyway, so let's jump to the 4-inch heavy-duty Frack 16C. Now we call this the Frack fitting, but really what it is it's a fairly high, it's a higher pressure fitting and attachment. So it's designed for a 4-inch frack hose, but it could be used on a 4-inch transfer hose that needs a little extra oomph and attachment. It's a heavy wall, Schedule 80 fitting, whereas the standard combination nipple was Schedule 40 pipe. The Crimpnology nipple, Schedule 40 pipe, except for the long shank, and we'll get into that. This 4-inch heavy-duty frack is also a Schedule 80 fitting. And the ferrule that is commensurate with that is a heavy-duty F suffix ferrule. So you'd have the part number, and these ferrules will all have an F on the end to denote the Frack ferrule. That is a 0.120-inch wall ferrule, as opposed to a standard ferrule, which is 0.095 inches. And this combination, crimped according to the crimp chart, Campbell crimp chart, will get you to a 400 PSI rating. And everything that Campbell puts performance ratings on and publishes carries a 4-to-1 safety factor. So this is a 4-inch oil-filled frack hose, designed product, but can be used for any other heavy-duty application on a 4-inch hose. So there you have it. This is a picture, again, taken in Williston, North Dakota. You can see it's a 206 hammer union, actually, that's threaded on to a 4-inch frack fitting, Frack 16C. And this picture is interesting because you can see why they call it a hammer union. The nubs on that nut have seen better days. There's not much left of it. So the figure 206 and figure 100 hose unions, these are integral one-piece hose unions. So whereas this picture is threaded on to the Frack 16C, this product eliminates the leak path of having to thread the union onto the nipple itself. The design is the same in terms of the machined steel forgings eliminating porosity, but the precision machined Campbell Crimpnology variable pitch serrations are the same on this shank as they are within the Crimpnology family. These are fully tested and documented and designed to exceed the 4-to-1 safety factor for working pressure. And the ratings are on the bottom, but it's an integral ferrule stop. Is machined into the stem, so when you drop the ferrule onto this stem, it actually seats in the groove, very easy to align in the crimper for final crimp assembly. And a retaining snap ring is installed behind the nut, so the nut does not flop around and become an issue during assembly. So whether it's the figure 100 or the figure 206, the 2-inch achieves 500 PSI rating with a standard ferrule. 3-inch in both figure 100 and 206 achieve a 400 PSI rating with a standard ferrule. And the 4-inch achieves the published 400 PSI rating you will use the F suffix Frack ferrule, that 0.120 inch heavy wall Frack ferrule, to get to that 400 psi rating. And of course, all of them with a 4-to-1 safety factor. So this is a picture, again, from the oil fields up in Williston. Those actually, if you look closely, they are threaded on, but this is where the application to eliminate that leak path from the threads is perfect. I didn't have a one-piece photo to show you guys, but you can see an oil field that's just used quite frequently. So flanges and turnbacks, generally used for material fluid transfer applications. Again, I mentioned the turnback picture, and here it is again. You can see it's just got a lip on it. That is in that photo there on the left-hand side. That's the turnback designed for a floating flange. So it drops over the fitting itself and then can be rotated for assembly procedures. So the flanges and turnbacks accept the ferrules, standard ferrules, into the interlock groove. And the working pressure ratings for those, you can see 1.5 inch turnback and fixed flange at 325 psi, up to 8 inches with an 8-inch ferrule at 175 psi. And those carry the same 4-to-1 safety factor as all other Campbell products in this class. Flanges and turnbacks are obviously 1.5 inches through 8 inch. Steel and 3/16 stainless steel. So chemical applications where appropriate, the 3/16 stainless steel is invaluable, and Campbell manufactures these in Boyertown, Pennsylvania, and sells a whole bunch of them for certain applications. Now we get into some interesting stuff here. The Criminology Swivel. Not all of you are going to be perhaps aware of this. 3/4, 1 inch, 1.25, 1.5, and 2 inch in plated steel and 3/16 stainless steel. Again, made in Boyertown, Pennsylvania. So this product was designed with installation in mind. You know, in the past, people would take a standard nipple of some sort to be used in the hose, and then kind of jury rig a JIC on the end of it for the swivel. So wherever swivel will help during installation is where this is used. This is not a live swivel. So this is a good picture of it, and you can see that wrench hex for the actual installation of the part into whatever. If you're going to thread another fitting on the end, or if you're going to thread this into a drop, that hex area comes in handy. So here's the Swivel Crimpnology Nipple PDF. And actually, anytime you see this, and you saw this once before with the 206 and the figure 100, these are PDFs. They're available from Campbell, from any of the salespeople. At the end, I'll have my email address. But you can get these from any of your salespeople for Campbell or Ideal Trident. And so the features on this Criminology Swivel nipple swivel, you'll see the same details on the left-hand side. The relief bump, they call it the smooth end detail, but it's a relief bump, rounder serrations toward that relief bump end, sharper serrations toward the threaded end. The interlock groove, which accepts the ferrule to get to the higher pressure rating, and of course the swivel hex body. So the 360-degree swivel rotation in features and benefits is for easy installation, and the swivel is not for continuous rotation application, so it is not considered a live swivel. It's designed for use with the standard ferrules. 3/4 and 1 inch use standard ferrules, and 1.25 through 2 inch use the long ferrules. Again, the hex wrench flat, and it is a Viton O-ring and snap ring inside to cover most applications. So the interlock groove gets you to the ferrule it holds it in place for ultimate holding power. So that you have that ferrule mechanical interlock. Graduated serration pattern, we went through the rounded and sharper serrations. And the shank and ferrule lengths are matched. So it's multi-purpose, chemical bulk handling, fluid transfer. So the Criminology Swivel performance ratings, if we look at this, this is a page from our Campbell coupling selection guide. The Criminology Swivel with a ferrule on a chemical rubber hose in 3/4 and 1 inch with a standard ferrule is rated to 500 psi. Then you see the long Criminology Swivel, which would take a long ferrule, is also rated to 500 psi in 1 1/4, 1 1/2, and 2 inch. And that's of course rated at 70 degrees Fahrenheit, and it carries the Campbell standard 4-to-1 safety factor for the attachment. Okay, so bear with me, we're almost through the woods. So here's the first poll question coming at you. And we're going to move through this once we see what's going on here. Thank you for indulging me. This is kind of the interactive part of the presentation, so I know you're not all passing out on me. I know there's a lot of information I'm throwing at you, but it's important to understand this. Well, you know, it's important to understand whether the bear picture is real or not. So, looks like we're done with the poll, and looks like we've got 54% yes, 29 no, and 17 photoshopped. And actually, that is a yes. That is that photo was taken on a trail camera at the family cabin outside of Steamboat Lake, Colorado. So interesting. All right. How do I, so this is a question you might ask yourself. How do I determine the safest nipple for an application? We've gone through the attributes of the standard combination nipple and the Crimpnology nipple family. So how do you determine the safest one? So first thing, this is critical. I don't care what presentation you're on that emanates from the Campbell salespeople, you're going to see something about stamp data. These are critical questions in every case. And I know when we talk about this, that a lot of times you'll say, yeah, I know, I should get this information. And sometimes it's hard to get the information because people don't necessarily have exact answers. And we'll go through it one at a time, but it's very important to try and push for accurate information in the stamp data area. So the size is just the hose, nominal size. That's kind of self-explanatory. If it's going to be a 2-inch hose, then obviously you would know that. Temperature, whether it's the media or the ambient temperature, this is critical. This one's big because as temperature goes up, your safe working pressure must go down. And the reason for that is really quite simple. As you elevate temperature, just think of what happens to a rubber hose or a rubber base hose as the temperature elevates. It starts to get soft and ultimately either turns to goo or burns or melts. And so it's much more difficult to keep the fitting attached to the hose as temperature rises. So therefore, working pressure must come down. Safe working pressure must come down. The A is for application. What is it? Is it a chemical hose, petroleum hose, water hose, etc.? The M is for media. Is it hydrochloric acid, diesel, sewer bypass, wine? It could be almost anything. You'd need to know that. And of course, pressure. And this is working pressure. What is it actually being used at? Not the ley line. So I know it seems easy to just say, well, it's a 250-pound hose, so 250 pounds. Not necessarily. We need to know if it's a 250-pound hose, is it being used at 100 psi, or is it being used at 240 psi? That might make a difference in the fitting and attachment selection. Of course, E for ends, whether it's male, NPT, cam locks, ground joints, etc. And D for delivery. That would be the requirements to your end user. So just say no to unsafe fittings and attachments, get the stamp data, and educate the end user with the Campbell Coupling Selection Guide. And here's another poll question coming at you. And this is one that not quite as goofy as the last one, just to get an idea of what the actual knowledge, not knowledge, but experiences out there for who I'm talking to. So we'll let this go for a little bit longer and see what we can see. So we're up to 83%, 89%. Holy mackerel, you guys are awesome. 91% voted. And so what we're looking at is 91% voted with a 62% yes and 38% no, and that's awesome. So that is fantastic. So this is the Campbell Crimpnology, the Campbell Fittings Coupling Selection Guide. So a whole bunch of you are familiar with it, and some of you are not. And the reason I bring this one up as being very important, just like the stamp data, once you have the stamp data, you can use this document to select and determine whether your selection is going to be safe and appropriate for the application. We also call it our pressure rating chart, and it is available as a PDF or printed. So again, get a hold of your salesperson and ask them to send you the PDF version, or get a handful of printed versions. It's 4 pages. On the inside of the document is a sample ASTM D380 test result, because everything we do at Campbell in order to publish these ratings has been tested. So it's a very important document, and it is a document that you can hand out to your end users. It's not inside information. It is published pressure ratings, and this is a good opportunity to educate your end users as to why you're recommending perhaps one attachment over the other. So let's go into that a little bit deeper. So your customer comes into the shop and says, this is your end user. It doesn't really matter what hose it is, but I need a 50-footer with male ends. We've all heard that many, many times. And what they're saying is, for those who don't know, is I want male pipe threads sticking out of both ends of the hoses. So here's what we have that we've gone over so far. If we start from the shortest on the right-hand side, that is a 2-inch standard combination nipple. You can see the male threads at the end. And that one, the mating sleeve, is a short sleeve, not a ferrule. In the center, you have a longer shank, but not long shank, 2-inch standard Crimpnology nipple that has the groove to accept the ferrule, and then the standard ferrule, which is the mating part sitting in front of it. And these are all 2-inch, so these are all the same sizes. So you get that relative size increase when you go from a standard Crimpnology nipple to a regular Crimpnology nipple to the, on the far left, Schedule 80 2-inch long shank Crimpnology nipple. It's a longer shank with more serrations, and those serrations are covered by the long ferrule, which is sitting in front of it. So the shank and ferrule lengths are matched to each other. And that's important because you want to cover the serrations to compress the hose into all the serrations, but you do not want the sleeve to be short of the end of the fitting itself or longer than the end of the fitting itself. You'll get either premature tube wear from a shorter than than needed attachment, or you would get premature cover wear if you've got too long a ferrule or sleeve on a particular nipple. So let's take a look individually at the 2-inch standard combination nipple with its mating short sleeve. And you'll see now this is actually a picture I took from the Campbell Coupling Selection Guide. And on that highlighted area, you'll see the combination nipple short sleeve, and you go over to 2 inches and you'll see it's rated to 225 PSI with a 4-to-1 safety factor. If we look at a 2-inch Crimpnology nipple with a mating standard ferrule, you can look in the highlighted area. Crimpnology nipple with a ferrule and a chem rubber hose is rated to 300 PSI. So you can see just adding a few additional serrations and a ferrule with a mechanical interlock, we went from 225 PSI to 300 PSI. Now we get into the Schedule 80 2-inch long shank Crimpnology nipple with the mating long ferrule. And again, when you go to crimp these, in your crimp chart, it will tell you that you need a long ferrule for the long shank. You don't have to know this stuff. It's right in front of you in the crimp chart. And you can see in the highlighted areas that the long Crimpnology nipple with the long ferrule and 2 inches, 1,000 PSI. So we went from 225 to 300 to 1,000 PSI. So with your stamp data, and this is the next slide right here, this one is an important table, and we'll kind of wrap this all together. This is the hose system pressure derating multiplier for elevated temperatures. Remember, we talked about the elevated temperature being so important in the stamp data. So this gives you an idea. The row we use for most applications and hoses would be all other. And at 200 degrees, you'll see that your multiplier is 0.42. So if we go back and we look at the long Crimpnology nipple at 1,000 PSI, let's say that you had an application where 200 degree water or anything 200 degrees was running through the hose, and it's a 250 pound or higher hose working pressure rating, you may need the 1,000 pound long Crimpnology nipple because you're going to need to derate that by 0.42. And your long nipple, which was 1,000 PSI connection at 70 degrees, is now a safe 420 pound connection at 200 degrees. So when you're talking to your end user, this is the stuff that you need to explain to them to educate them. It's very critical that they understand that you are the smartest guy in the room from an application standpoint, and what you're providing them is safe, leak-free attachments on the hose. So, are you asleep yet? This happens to be one of my 2 sister dogs. So, get your questions in. We'll answer them at the end of the presentation here in a moment. So, if you have a question that came up, please type it in. So, in conclusion, all applications require the fitting to stay in the hose and the hose not to leak. That seems kind of self-explanatory. How do you do that? Campbell crimp specs. They set you apart from the competition. Now, this is not the Campbell Crimpnology webinar. That one was this morning, and again next Wednesday in the afternoon in this time slot. So I encourage you to watch that to get more information on what we're talking about, the Campbell crimp specs. But it's very important because that is what gets us to our published performance ratings in the Campbell Coupling Selection Guide. Critical applications, they require more scrutiny, and the stamp data you collect is paramount. I think we all know that if somebody's pumping water from a ditch into the field, our stamp data is not quite as important as if somebody is transferring elevated temperature acid from one vessel to another. that becomes very critical, and you would not want it to blow off or a leak with that transfer. So, force the issue on temperature, media, and working pressure as necessary. You guys are out in the field, most of you, not everybody's probably a field salesman, but those who are, hey, if somebody says it's hot, say, how hot? And if they say, I don't know, well, maybe you should dig a little deeper. And the media is important. And working pressure as necessary. Obviously, working pressure is not the ley line of the hose. And so use the Campbell Coupling Selection Guide. Get it in PDF form, print it out for yourself, or get printed copies to ensure that what you're providing for your end user meets the safety and application needs. And just say no to cutting corners. Don't mix and match and think that the guy down the street is providing something so much cheaper when he may actually be providing what would be a standard combination nipple when a long shank nipple is required to maintain a safe system and hose assembly. And educate the end user. If you educate the end user with the Campbell Coupling Selection Guide, I pretty much guarantee you over time, you will win their business. So, questions and comments. Courtney,
Yeah.
or I guess it's Tommy. Tommy,
I got
you got any
Chris.
questions?
Yeah.
All right.
Yeah, we'll start with the most important one. We had a question come in asking if the dog in the slides was the one we heard barking, or if it was the sister.
Yes, I don't know which one it was, but there's only one left now because she barked when she wasn't supposed to. So, no. Anyway,
here was a question. Does the temperature derating chart apply to just pressure applications, or can it be applied to any vacuum applications?
well, since there is no pressure in a vacuum application, it would not be applied to vacuum applications. So the temperature derating is only for pressure applications. Vacuum has no pressure, so you're not going to suck the fitting inside the hose. If it's very elevated temperature on a vacuum application, then I would check with your Campbell salesperson who can get to Campbell Engineering. Obviously, you shouldn't be using a hose that's going to actually melt or turn to goo, even in a vacuum application. So my inclination is to say there is no derating for vacuum, but if there's an issue, we can check for you.
Nice. All right. Where can we where can we tell people to go get this coupling selection guide? What are our avenues?
Well, the avenues, actually, you can call Campbell Fittings at 800-367-3678, and they can provide the link and or printed copies for anybody who would like it. You can get a hold of me. My email will pop up right after this slide and be on there for a minute or two. It's quite simple, Chris Cooper at campbellfittings.com. But it is available as well through any of the regional salespeople that work for the Ideal Trident Group.
Yeah, and also the website in the tech center, you're going to be able to find it right there for your own ability to download the PDF. And also in that section, we have the temperature derating, flow charts, force charts, other cool tools. Next question. We got a few. All right. What is the best way to insert the one-piece 206 union? I guess they're having some issues with the snap ring falling off when they're using a mallet to insert the fitting. Got any advice there?
Well, the Frack hose is a pretty beefy hose. You can use as much water-based lubricant as you can possibly use the fitting itself is not oversized, so beating the heck out of the end of it, yeah, you can pop the snap ring and move the nut. You could obviously, if the nut pops off, you can get the snap ring back in there if you so choose. But that's the best way, would be to use lubrication and a hose pusher. Hose pusher with a block inserted so it's just on the fitting and not on the nut.
Yeah, the hose pusher is pretty sweet. All right. Can I put a combination nipple with a sleeve on a 250 psi hose?
Well, you can. You can do anything you want, so to speak. But the combination nipple with a short sleeve is rated to 225 psi. So if you're putting it on a 250-pound hose, one of the things that you really need to pay attention to is that out in the field, the only thing that the operator or end user sees is the ley line on the hose. So if the ley line says 250 psi, you want to make sure that your attachment covers the 250 psi, simply because you never know when an end user might, be standing there saying, "All right, crank it up, Johnny. This thing can take 250." And you really don't want to find out the exact ragged edge of the performance of any of this stuff. We want to maintain a significant safety factor. So I would say it's not a good idea to put that on a 250-pound hose.
Nice. All right. Last question. Is it the sleeve or ferrule length that makes the biggest difference in the pressure ratings?
Well, actually, it is not solely the sleeve or ferrule length that makes the biggest difference. It's a conglomeration of everything. So your shank, the mating length of the shank to the sleeve or ferrule, the number of serrations, the mechanical interlock using the ferrule, and then whether or not you have a long shank or a standard shank. So that all contributes, all the design and machining and the engineering contribute to the actual performance rating that we publish. So no, it is not just the length of the sleeve or ferrule. It has to do with the number of serrations underneath it. Okay, is that all the questions?
Last question that just came
in
was just getting a link, and yes, it'll be in the follow-up. Sorry, go ahead, Chris.
Okay, so this is my information. There's my goofy mug, and so if you need anything, you can email me right there at chriscooper@campbellfittings.com. The 800 number is the Campbell direct number, so if you want more information, just contact us. And thank you very much for putting up with this information dump on this particular webinar, and hope you enjoy the other webinars in the Ideal Trident Connections family of webinars coming out in the next 3-4 weeks. Thank you. Bye-bye.